Hi, and welcome to our presentation on Tesla, Information Technology Transformation through ERP Simplification and Early Stage Growth. This technology plan will be presented to you today by the following team members: Cynthia Gallo, Darren Raleigh, Frank Wagenseller, and Yusun Ho. We would like to briefly summarize phases 1 through 3, which will give a bit of a background or understanding as to how we got to the technology plan we are presenting to you today. So to quickly cover the industry analysis, the industry that we're focusing on is the plug-in electric vehicle market, or the PEV market. We chose this market because it is rapidly growing. The current statistics of sales shows that it's expected to reach 5.2 million units by 2020. In addition to that, in 2013, sales had increased over 228% from the prior year. So from these quick facts, it can be shown that the PEV market is booming and is constantly increasing and growing. Now for the company analysis, we chose Tesla as it is currently the market leader for PEVs. They focus on a few key activities such as technology, vehicle design and engineering, sales and marketing, service and warranty, and manufacturing, with having involvement with key partners such as Toyota and Panasonic. For the transformation plan, we recommend for Tesla to adopt and build upon their custom in-house ERP and SCM application. With this recommendation, we strive for Tesla to be able to centralize their key suppliers to focus on one core group of suppliers during the production of their Tesla vehicles. Also to implement specific functionality to Tesla through this custom ERP and SCM system. Quick implementation, a system that is easy to customize. And lastly, in-house support and maintenance with the in-house resources that Tesla will have.
We are proposing Tesla to utilize Amazon Web Services private cloud solution. Amazon private clouds offer ranges from basic Windows Server hosting to host a business intelligence application. Amazon also have 10 different data centers worldwide. This will give Tesla the flexibility to expand to any region worldwide quickly. Here is an overview of the proposed architecture. We will start by talking about Tesla's current in-house ERP and SCM. Our proposal would migrate Tesla's current in-house ERP and SCM to Amazon's private cloud. As part of the proposal, we have broken Tesla's ERP and SCM architecture into several tiers. The core ERP and SCM for main component and manufacturing, a regional ERP, SCM, and Citrix server farm to support vehicle assembly activities, a regional e-commerce server farm. Additionally, a regional Citrix server farm can be added for that country as need arise. With this tier structure, Tesla could now create server templates in Amazon private cloud, and using these templates, Tesla can quickly build out new infrastructure in new location quickly. Once a regional system is built out, depending on traffic, each tier can also be scaled horizontally by adding extra servers. Besides the tier structure, the proposal also includes migrating both business intelligence and data warehouse to Amazon private cloud to simplify data consolidation, transfer, and analyzing of data. Now, we will take a closer look at how each regional system connects. As Tesla expands globally with regional assembly plan, different e-commerce system for each region is required. So each can perform inventory lookup and allow local user to place order at the appropriate assembly plant for processing. Each regional ERP and SCM would then send information back to data warehouse for analytics.
After carefully considering the level of effort required to successfully implement the homegrown ERP and supply chain management model integrated with suppliers, we are confident the project development will take 24 weeks to complete. This will once again be comprised of hand-picked assets to include the skill set necessary to complete the project in the time allotted. During the initial implementation of the systems, this team will include a larger group that will complete the implementation in the 24 weeks. Once implemented, the team will be pared down to the core group as indicated in the support quantity column, and this will include the internal systems support team. This includes a project manager, business analysts, applications developers, systems engineers, database administrators, database architects, systems administrators, systems engineers, and systems analysts. For training, the team feels confident this initial training will be accomplished in 12 weeks. This training will consist of supplier integration and training services and will include the core suppliers to provide the common data dictionary, which will help streamline processes and prevent misunderstandings or delays caused by uncommon terms or phrasing. The training will be conducted using a train-the-trainer mentality. The goal is to train the users who are determined to be the trainers in their given areas. All the materials will be provided to these trainers, who will be able to provide end-user training designed specifically to work performed by user groups. Both the train-the-trainer and end-user training services will be documented, and information will be maintained in the database to show training dates and areas in which personnel are trained.
Some key assumptions we have made with building the in-house ERP system over implementing a well-established enterprise manufacturing system such as Oracle or SAP is that the system is going to create incremental operational efficiencies throughout the supply chain, which will lead to increased production output. It is estimated that as a result of the efficiencies of this system and the way it integrates with suppliers and facilitates the movement of production through the supply chain, production output will increase by approximately 10% a year. Another key assumption which drives our financial model is the variable cost this ERP system will have per vehicle produced and the variable incremental revenue which can be attributed to the development of the ERP system per vehicle produced. We assume the home-built ERP system will cost 2% of each vehicle built, or approximately $1,512, and 5% of each vehicle sold, or $3,500. Based off Tesla's most recent public 10K filing, we have calculated the average revenue per vehicle at $70,000. This includes the zero-emission vehicle, or ZEV credit Tesla earns, which they can then sell to other non-battery electric vehicle manufacturers. The initial application development cost is estimated to take 6 months. We plan on putting a team of 20 application developers, 10 business analysts, 8 system engineers, DBA, system admins, security engineers, and security analysts. The total application build expense is expected to be $6.7 million. Ongoing reduced IT support team with an expected makeup of around 50% of the initial development level is estimated at $7.2 million per year. The team recommends hosting the new technology environment in a managed, secure, single-tenant cloud environment. The upfront costs of the hardware and software will be depreciated by the vendor over a 3-year period. Expenses for this portion of the environment are expected to be roughly $510,000 annually. We're going to wrap security services around this infrastructure to ensure ISO, PCI, and SSA 16 compliance for approximately $140,000 annual cost on top of the hosting. The total 1-year cost initially is estimated at $14 million with a recurring annual cost of $7.9 million. So what we're looking at this point is an annual infrastructure expense of $510,000, annual security expenses of $140,000, one-time application development of $6.7 million, and then total 1-year expenses of $14 million. Regarding revenue analysis, our worst, most likely, and best case revenue is based on incremental production increases as a result of the implementation of the in-house built ERP system. With the most likely scenario of 5,000 incremental gross production revenue, we're expected to be at $17,500,000. Our worst case scenario estimates production at 4,500 vehicles and incremental revenue at $15,750,000. The best case scenario is 5,500 vehicles and $19,250,000 in incremental revenue. All of these calculations consider the zero emissions credit. A 3-year profit estimation of the ERP investment and revenue shows a first-year loss of approximately $4.1 million in the current year, followed by positive returns in year 1 of $6.2 million, year 2 of $10.9 million, and year 3 of $18.9 million. These figures are based on the staggered launch of the Model X and the Model 3 in years 2 and 3. Also important is the incremental revenue attributable to the ERP system per vehicle and the variable costs of the ERP system associated per vehicle. The incremental cost of the ERP system is $1,512, and the incremental revenue of the ERP system is $3,500. A detailed break-even analysis starts with the initial investment cost of the ERP system of $6.7 million. Then taking the annual fixed operating cost of $7.2 million and matching this against the variable cost and variable revenue, we arrive at a break-even point of 7,050 units or $24.6 million. We've chosen to assume that over a 3-year period, given costs and revenue for the Model X, the Model 3, and the Model S, that the $3,500 revenue and the $1,500 expense, that this will remain an average, and that the $24 million break-even point is actually a low number, and that the ERP system will probably break even much sooner than this. Looking at a 10-year return and production run for this investment, the break-even point occurs in year 2. Over the course of 10 years, given an incremental production output of 143,500 units, which we consider conservative, the project nets nearly $199 million in today's dollars, or has an NPV of $114 million and an 8% interest rate. Tesla's return on this investment is very attractive. Given the investment plus the annual fixed and variable costs and the annual revenue from the investment, we're looking at a negative 50% in year 1, turning positive in the middle of year 2 to 29%, 45% return in year 3, and then increasing from there.
The project schedule timeline proposed to Tesla is an aggressive 24-week build-out plan. The project schedule will consist of the following 5 phases. Phase 1 will be discovery and planning. Phase 2, design and configuration. Phase 3, system development. Phase 4, testing. And lastly, Phase 5, go-live deployment. Phase completion will be milestone indicators throughout the rollout of the project. The project is proposed to start immediately on December 15, 2014 to commence planning. This will allow Tesla to start the new calendar year in designing and configuring its in-house ERP and SCM application.
After implementation and training, these key metrics will be monitored. Based on the implementation of the homegrown ERP and supply chain management solution, we are expecting a 5,000 unit increase in year 1. The production lines will be monitored to ensure throughput does not drop below the expected daily output per production line or the given functional area. These numbers can be adjusted by setting parameters for different vehicle manufacturing types. In order to improve the production time and meet the 4-hour average cycle time for production of the vehicle, the assembly line times need to be monitored through the supply chain management tools. Any deficiencies in service will be documented, and this will require a follow-up by management within the area not meeting the times to address the issue. The average turnaround time for parts to be delivered by suppliers must be reduced to 2 to 3 days. This time is counted from the time the part is requested into the system and tracked through delivery. Any deviations will trigger an alert for service failure. A weekly report card via the dashboard will be provided to show program compliance. In addition, once a service failure is identified, the average time to resolve the issue must be less than 4 hours. This will be monitored through the collaborative communication will be identified in the 2 to 3 day turnaround. Once triggered, this will send a high priority alert indicating the potential for delays in production. Updates regarding the service failures must be initiated by the suppliers through the vertical communication. With the increased visibility by suppliers, essential part availability should not be an issue. The expectation is that there is less than 1% unresolved issues with parts supply. This will be monitored through the integrated supply chain management tool and should be captured in the 2 to 3 day turnaround time.